Identify the dissolution equation and Ksp expression. The compound PbCl₂ dissociates in water according to the following equilibrium. PbCl₂ is in equilibrium with Pb to the power 2 plus 2Cl to the power negative. The corresponding solubility product expression is Ksp equals Pb to the power 2 plus Cl to the power negative to the power 2. Determine the concentration of lead 2 ions. Because Pb, number 3, 2 is a highly soluble strong electrolyte. It dissociates completely in aqueous solution. A 0.010 molar solution of Pb, number 3, 2 results in a Pb to the power 2 plus of 0.010 molar, or 1.0 times 10 to the power minus 2 molar. Identify the condition for precipitation. Precipitation begins the moment the ion product, Q, reaches the value of the solubility product constant, Ksp. To find the lowest concentration needed to begin the process, we set the Ksp expression equal to the given constant. Set up the calculation. Substitute the known values into the Ksp equation. 1.6 times 10 to the power minus 5 equals 0.010 times Cl to the power negative to the power 2 solve for Cl to the power negative to the power 2. Divide both sides by 0.010, which is 10 to the power minus 2 Cl to the power negative to the power 2 is equal to 1.6 times 10 to the power negative 5 over 10 to the power negative 2 is equal to 1.6 times 10 to the power minus 3. Calculate the final chloride concentration. Take the square root of the result. To perform this mentally, it is helpful to rewrite 1.6 times 10 to the power minus 3 as 16 times 10 to the power minus 4. Cl to the power negative equals square root of 16 times 10 to the power minus 4 equals math 4.0 times 10 to the power minus 2 molar conclusion. The lowest concentration of Cl to the power negative needed to begin precipitation is 4.0 times 10 to the power minus 2 molar, which matches option E. The correct answer is option E, 4.0 by 10 to the power negative 2 molar.